Do I know? At least one.
Because don't work for real.
I did not hear what you said.
Oh, this day. Last year, I was
All right, sit down, shut him up. You got already. We got a lot to do today. There's no time for me to be correcting you all. That's wrong already. We're trying to get through a lot of material that's we're not going to get through all of it, but at least we did in last class. Although they do have the announcements still, so we might get through a little more. But do that. I'll give you like, if you didn't hear me earlier, you need 2 pages of the graph paper, so you can come grab that.
2 pages.
Yep, 2 pages.
2 pages.
Those.
Yeah.
Somebody will count them out for you, Miles. Somebody count to 2 for Miles.
We should have definitely posted. Yeah, all right. Search here. Thank you.
Everybody has 2 pages. 30 more seconds.
You definitely said. Oh, God. Oh, you just going to hell. Yes, you did.
Those nice shoes.
Got to give her this.
Maybe. Totally forgot. Totally forgot the last time. They're gonna be mad.
I remember.
I know. What the hell was that? I get some. I get one.
We'll see.
They're right there.
He's not having to correct this class. All right, so what does a rotation mean?
Around.
Or what's that word mean? Like rotate.
Around.
It's a turning, right?
Yeah.
All right, so again, so you have your quiz on, there's 2. I mean, literally, I'm yelling as loud as I can yell, so talk over. I'm gonna do that. No.
When can I take the test?
1 time. You could probably do it in 1 lunch.
You take it?
I think, yeah, that was a short one. That was only 5 questions.
No, I ain't taking it.
All right. So on the next quiz, we're gonna do what's called transformation. So that's the lesson for today. We'll do part of that, and then we'll finish it Thursday. But I'm also on Thursday going to give you a review on something that was on the last quiz, which I will also be putting on the next quiz. If you do better on that, since you would have then had 2 lessons on it, it was that tough problem where you figured out the distance between a point and a line. If you do better on it, then I'll add points to your previous quiz. So it's like a retake without you having to come in and doing a retake on, lunch. So we'll do that on Thursday, but we've got to get through these 2 pieces today. Actually, we don't do rotation today. We do reflection and translation today. If we don't get through that, I mean, I'll still put it on there, but you may not get the review, so I don't know how much it's going to help you if you don't get the review on Thursday. All right, so what's reflection mean? Mirror is what, right? There's some kind of a mirror image. It is, the word we're going to use actually flip. We're actually going to be flipping an image over what's called a line of reflection.
This reflection.
Yeah, I'm recording, so we're good. All right, so today we're going to do 2 of the 3 transformations that you're going to learn. Actually, you're going to learn 4, but one of them is next semester. So we're going to do reflection and translation, but go ahead and you don't have to copy all of that down, just kind of like what's highlighted.
There's some black person out the door. This tall African.
There, just copy those buzzwords there, or those keywords. So again, you're not writing all of that. You're just writing what's highlighted. A reflection is a flip. You need to write line of reflection. I'll define that for you later. And then a translation is a slide. That's all you have to really write for that one. And then a rotation is a turn, and we turn around. It's called a center of rotation. If you want, you can, again, that's the only thing we're doing, so it doesn't really come into play unless the district does something different. But what we're going to do when we do rotations on Thursday is just around the origin. We're not going to try to do it around just a random point on a graph. That's much more complex. And I don't even know if that's tested. I didn't think it was. Somebody else said they thought it was. So we're still not going to do it. One more. There you go. And you got a lot of quarter left. You might need a calculator today if you want to grab one. There's some adding and subtracting. So it's not super complex. Like you still have some positive and negative. I gave you 30 more seconds and we're moving on. So you're just sitting there chilling, right? It'll be recorded. You can go back and fill your notes in if you need to, which I'm sure you would all do.
What lunch you have?
I have a second, but it doesn't matter what you have. If you're doing a retake, you just come in, and if I have kids, you sit right there.
I ain't even doing a retake. I ain't taking. I wasn't even.
Well, I mean, you know,
Yeah.
I'm taking. Oh, right. You do need this word up here. Again, just write on a separate line. So you do need that word rigid on a separate line. I'll define that for you as well. All right, so we've kind of already talked about what a reflection is. We're flipping an image. We're gonna take an image and we're gonna translate it. So a translation is a slide. And then we're going to take that image and we're going to maybe rotate it, which is a turn, but it's not really just a turn of the image itself, like does it twist? It actually kind of rotates all the way around the graph. That's going to be what we're going to, that's why I'm saying we're only doing it around the origin. Because if it's around the origin, then basically the whole graph spins. So it's not that the image spins, the graph itself spins, which makes the image spin. All right, so with these three things in mind, I'm going to still do this over here, even though I am sitting there in this class. Yeah. Oh. All right, so I can't really duplicate this. I guess I slowed it in a couple more, but I'm just going to do it visually. So if I have a shape, could be anything. It could just be a single point. It doesn't even have to be a shape. You can translate, reflect, rotate a single point. Sounds kind of weird, but that's actually how we wind up doing all of it. So a translation, if this image starts here, a translation is a slide. The image itself does not change its what's called its orientation at all. It doesn't twist, it doesn't flip. It just slides. It just moves around like that. That's the translation. Easiest one, in my opinion. It's the easiest one by far that we'll do. We do that one first today. If it is a reflection, the image will actually flip onto its other side. So it actually flips, and it flips over that thing called the line of reflection, which can be in a lot of different places. So it could be the y-axis, so we flip over the y-axis. It could be the x-axis, so we flip over the x-axis. It could be a diagonal line. It could be just a horizontal line way up here or a vertical line over there. The line of reflection could be anywhere. Some of them are a little tougher than others for sure, but there's a process that if you follow, oh, and I forgot rotation. There's a process that if you follow, I don't think reflections are too bad. Rotations, again, don't think about this thing spinning. Think about the whole graph. Like if I could take this whole graph and turn it, well, that would make this move with the graph over here. And then if the graph turned again, here, the actual graph, the quadrants themselves are turning. The whole thing is spinning around the origin, around that point. We don't get to that until Thursday, so I'm not super worried about that. So today we're doing translation slides and reflections, which is the mirror image, the flip. One quick other definition. All three of these, you need to know this. This has been a question every year that I've seen on either practice stuff or in the district stuff. Yeah, I don't get to see the state test, the EOC. A rigid transformation means that the size and shape of the object, the figure, stays the same. It doesn't like get skinnier. Actually, skinnier would be it doesn't like get skinnier up and down. Doesn't get fatter, like widen out left and right. It doesn't shrink down, even it's staying in proportion. It doesn't like shrink down. It doesn't get larger. All we're doing is we're moving the image around. So in all these down here, you see that the original image and it's actually called pre-image and image. They are the same size. If I were to flip this on top of that, since it's a reflection, it would land exactly on that triangle. They would match up perfectly. They're the same size image. That's what a rigid transformation means. They are the exact same shape still. Same size, same shape. Nothing is different. We just moved it somehow. So in a slide, we just move it. In a rotation, again, we're rotating the whole, all that rotates all the way around that particular point, that center of rotation. And again, we get to that Thursday. A reflection is kind of, this is the way I think Mr. Fisher actually keeps it. A reflection is kind of like just folding a piece of paper along the line of reflection. If we just folded it, and if we had, you've probably done this before, where this was paint or a wet ink and you folded it and pressed it down, it would make the other image for you. I don't know that that's going to be something you can do in an EOC with the materials they give you, so I'm not going to teach it that way. I think Mr. Fisher does that. He also does stuff with tracing paper. Again, you're not going to get tracing paper, so I'm not going to do that. And then there's a way to do it with formulas, but again, you'd have to memorize all the formulas, and that would be pretty tricky, especially for the EOC. So we're going to learn it in a way that I think is pretty intuitive. So it seems to have worked in the past. So we went over all of that. Just make sure you understand these two pieces down here. The pre-image is the original image. We are moving that in some way. Sometimes we might move it multiple times. We might flip it and slide it, or we might rotate it and flip it. So we might move it more than once, but the original image and then the final image are those two vocabulary words. Pre-image is what you start with, and then just the image is what you end with. Whatever words you want to use to describe that. And then all the other ones, we went through all the other ones already. So, all right. So with that in mind, we're just going to create some images, some pre-images, I should say, and then we're going to do a translation first a couple of times. Then we're going to do some reflections, and we'll see how far we can get. So you didn't need, you should have already had all of that, except maybe the pre-image and images. I'm gonna go on, so if you need to go back and fill in your notes. The main thing you just need to know, this is original. Make sure you have a pre-image, original, image, final. Again, all that other stuff, you're gonna see that a million times over the next 2 days. Pre-image, original, image, final. All right. So there's a bunch of notation in this. I might print this out again. We don't use this stuff as much, but you could see a lot of different notation on the district and the state stuff. I don't know how they're going to ask you the question, which makes it challenging to teach when I don't know which type of notation they're going to use to ask. I'll point some of this stuff out as we go through, and we'll just go back and review it also at some point. So for right now, I want you to, on your graph paper, draw that triangle. Use these three ordered pairs. That should create a triangle that looks, yours will look different because my numbers go all the way up to 10. So this top number up here for Y is 10. Yours only goes to 7. So you will actually, the top of your triangle will be at the very top of your graph. You'll see what I mean. So again, don't draw it from the picture, use these three ordered pairs. And you'll see what I mean when you draw it. Create some. I think I have some somewhere. Couldn't find it. Actually, while you're doing that, I don't know where the points went. But dang it. So green would be -4. Blue would be -1. And there. All right, so there. All right, so again, now we'll slow down. Translation is not difficult if you know what they're asking you to do. So the hardest part is just to know all the different possible ways you could get asked the same question. Those 4 statements are all the same statement. They're telling you to do the same thing, just in 4 different ways. So again, and it could be a combination of some of those. They could even change those a little bit or combine 2 into 1 or something. Again, don't know how they'll ask it. So if you see, this is the easiest one, I think. If they say translate it right 2 units and down 1, then you're just moving the image to the right 2 units and down 1. If they say along a vector of 2, 1, that means your x values are going up by 2. So you're adding 2 because it's a positive 2. And your y values are getting lower or decreasing by 1 because you're subtracting 1. Kind of what's happening right here. That is kind of the same thing as that, just showing in a different way. Your x values are adding 2, your y values are subtracting 1. And then again, kind of the same thing down here. They're saying move that triangle, translate it. That's based on the T. Translate the triangle ABC. Oh. And it would have letters on it. Translate triangle ABC, right? 2 units, because the x's are +2, +2, down 1 unit, because the y's are subtracting 1. So if a y value subtracts 1, well, then it gets lower. 7 subtract 1 would be 6. So that's why it's down is negative. If the y values get smaller, then it's moving down. If the y values got bigger, you'd be going up. So if these were positive, you'd actually be moving it up instead of down. I'm hoping that's pretty intuitive because the positive numbers are getting bigger going that way. So hopefully up makes sense if it's positive. Hopefully down makes sense if it's negative. Same way for the x's. If I'm getting bigger going that way, I'm adding. So hopefully positive plus something makes sense that it's going right. Subtract on your x's hopefully makes sense going left. I think you're going to do plenty of these where even if it's not necessarily making sense, you're going to catch on just from the practice, assuming you were. All right. So now here's the next piece. Let's zoom in. Go ahead and write number one. Write number one and number four. Here, let me lock some of this in, and then I'll get rid of some of the extra stuff. You can read number. I mean, you should be able to read number one, no problem. There. So weird. Oh, that does. Oh. Oh. Actually, that's fine. So write number one, well, the top one and the fourth one, because they both say the same thing. Those are the two I think that are the most important. They give you the two different types of things you would see as far as just a two and a negative one. So when you are moving, well, you just there, if you couldn't see it as well, you're writing the top one, translate, right 2 units and down 1 unit. And then you're writing the bottom one that is just the T and the two and the one. The two and the one are like lower. It's called a subscript. If you don't know what a subscript is, it's like the opposite of an exponent. It's lower and written in smaller font. All right, so hopefully everybody's written at least the first one because you can still see the bottom one. So here's the first thing you need to know for translations and reflections. Do not think about this as moving that entire image at once. That is way too complex. Again, I'm not saying it's impossible if you're very visual, but it's a lot easier to just think of it as moving each point individually. So if I want to move triangle ABC, I'm just going to think about moving points A, B, and C, and then I'm just going to connect them all back. So if I want to move it with a 2 and a 1, then that means right 2. I mean, you've already written it down, but it means right 2, down 1. Well, I just move every individual point right 2, down 1. So go ahead, do that. I'm going to sort of go over actually, this is the equation right here. This is what the equation is. If you see a formula, it said x comma y, and then instead of a number being there, I think it's like x plus h or something like that, y plus k or something like that. They're just telling you you're adding some number onto the x and y values. In this case, the number you're adding is +2. There you're adding -1. I'm not teaching the formula way though. Right question? Not right now. I need to get through this one so you at least see translations. So now you can do that with every point. Go ahead and finish it off. Every point goes to the right 2, down 1. To the right 2, down 1. And that's your new image, or really just they call it image. The original one was your pre-image. The way you label your new image, if there are letters, is with a little mark like that. So each point is the new, new image, really just called the image. It's called A prime, B prime, C prime. That's what that little mark can be read. A prime, B prime, C prime. And then we would connect it, and it should look, symmetrical if you did it correctly. So that triangle looks like it's just been slid straight down. It doesn't look like it twisted. It didn't get smaller or larger. It just looks like it slid down into the right. Now, here's the last piece of this for a translation. There's actually another way to do it that doesn't even involve anything visual. And for translations, this works out pretty well. I would not going to do it at all for reflections, but you can just alter each individual ordered pair. Because we said really all we're doing is we're adding 2 to the x values. We're subtracting 1 from the x values. So for each value over here, for the x's, I could just add 2. Boy, I just butchered. Let's try that again. So I could add 2 to every x value, subtract 1 from every y value. If I did that, I would say, well, 2 plus -7 is -5. And then 4 subtract 1 would be 3. That better match up with what I did visually, because it's the same thing. And one of them just using a little bit of math, and one of them I'm visually doing it. So my new point better be at -5, 3. Well, let me make sure. 1, 2, 3, 4, 5. 1, 2, 3. Perfect. I don't care how you do it. You want to draw it, if there's not already a graph there, it might be easier to just add. If there is a graph there, it might be easier to just move it. I don't care as long as now you need to know how to give me a final answer both ways. So you need to know how to either convert your picture into the new ordered pairs, or you need to know how to convert the ordered pairs into a picture if I ask you to graph it. So make sure, but initially, I don't care how you get your final answer. So that would be -3, and -1 plus 7 would be 6. Well, let me just make sure. So my red point should be at my new red point, my A prime. 1, 2, -3. 1, 2, 3, 4, 5, 6. Perfect. So now I can do the same thing with the blue. Add 2. Subtract 1. Better be at -1, 0. Well, -1, 0 right there. So, translations. Either you slide it left or right and then up or down, depending on whether it's positive or negative, or you can just add or subtract the values onto all of the x's and y's. Remember, you got to do it to all of them because you're moving all the points. Any questions on that? That's it for translations, really. When you're going to do one on your own. All right, do this one. So now pick another graph. Use these points. I think it's the same points again, starting points. Go ahead and move that triangle in the correct translation. Oh, Vicky's not here. Well, she was supposed to go to this, but I don't even know what it is, but I've never ever seen that before in my life. Some math prep. I don't know what that is. My guess is maybe I don't know. It's the prep for SAT. I never gotten in that pass before. I'll give you another minute. Should not take a real long time, even if you're graphing it. All right. So again, I don't care how you do it. I'm going to do it both ways, but quickly. We can check your final answers, but it should always match up. So for my red point A, I need to move it. A 6 here means 6 to the right. Positive, that's a positive 6. Positive 6 for the X means right. And then 4 down, a negative 4. God, my board is off. 1, 2, 3, 4, 5, 6. 1, 2, 3, and 4. So it goes right there. And again, that would be called A prime. Now I'll do the same thing for B. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. B prime. And what's that? Oh, I'm sorry. B prime. And then blue, it looks like. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. B prime. And then again, connect them with lines so you can kind of just see. Make sure you're connecting the ones that are the new points, the prime points, not one of the old points. That looks like the same triangle, just slid down to the right. Now, just to make sure, let's add 6 and subtract 4 over here. See what we got? I'm not even going to change colors for this part. Negative 1, 0. Yep, negative 1, 0 right there. So positive 1, positive 3. So positive 1, positive 3. Yep. And what would that be? 3, comma, negative 3. 1, 2, 3. 1, 2, 3. Perfect. So all that matched up, so I feel pretty good about that. That's translation. Again, the only tricky part's going to be if I ask you on the quiz something like that, where I don't specifically say translate right and then down or left and then up or whatever, you need to know what that notation means. That's the only tricky part of it. Just make sure and there's only one of them that starts with a T, so since this quiz is only going to be about transformations, it shouldn't be too difficult to remember that. Reflection's definitely a little trickier. Go ahead and draw that triangle again on a graph. Then when you do the notes, it'll be up to you where you want to do the notes. If you also want to do it on the graph paper, or if you want to do it fast. Oh. So for now, put that on the graph. I'll scroll back up in a second and you can write notes. We're full. Put it up there, please. Pretty good about something like that. All right, everybody created that, or at least written the 3 points down. You can finish creating it. All right, so here are your notes. And again, there are other ways potentially this could get asked. Those, I think, are the 2 more common ways. So again, every reflection will follow that process. I don't care how complex it is. So write that process. That is the process for doing a reflection or reflecting an image or whatever you want to use, but we're going to take an image and reflect it. We'll do that process every single time. The key is the second thing, figuring out how to put the mirror line on. Well, actually, shoot, I don't want to call it mirror line. Let's call it line of reflections. We used to call it, actually, you know what? We did do this in middle school because I remember in middle school they called it mirror line, not line of reflection. So yeah, you probably did do this a long time ago. Drawing a dark, dark, dark line of reflection. I'll give you a minute to copy that stuff down. Well, I didn't do attendance. Actually, tell you what, I'll do at least second period's attendance while you're copying that. Hmm. Interesting. Oh. I never even checked in and clocked in. Mm-hmm. Oh, doing attendance. Is everybody done copying? Are you? All right, I'm gonna go ahead and get going. All right. So again, everything in reflections revolves around creating the correct mirror line. Once you do that, everything else is not too bad. Some of them are just easy. So in this particular problem, the line of I keep saying mirror line. The line of reflection is the y-axis. When it says across the y-axis, that means the y-axis is the line of reflection. So we're going to follow that process. We're going to ignore really everything except for the dark line of reflection that we create. So I'm going to ignore that x-axis. If there were numbers, I'd ignore the numbers. I'm going to darken in what is my line of reflection, the y-axis. So I can clearly see where I'm flipping, what I'm flipping over. I am flipping over that dark bold line. The X means nothing to me. None of the other grid lines matter. That is the only line I'm flipping. Now it's just, who wants to be a volunteer? Come on. Super fast volunteer. I actually forgot to do it. Let's do it. So we are a mirror, right?
Yeah.
So we're a mirror. So if I do this, what happens? Right? If I do that, what happens? Oh, told you. So again, it's closer or farther depending on what happens, right?
Yeah.
Fantastic job. Now you use that same concept. Points that are closer to the line of reflection, when you flip it, will be closer to the line of reflection on the other side. Points that are farther away, when you flip it, will be farther away from the line of reflection. And they're really just going to be the same exact distance away. So all you do is you just say, okay, well, if that's my line of reflection, and if this red dot is 5 units away, well, then I need to put a new red dot 5 units away, but on the other side.
You got to flip it. You got to flip something.
Again, do not think about flipping the image. Move every individual point. Then just connect them. And then you do that with all the other points. So if you want to just finish it out real quick, you can. So again, now I'm going to go to the green dot. Green dot. 1, 2, 3, 4, 5, 6, 7 away. Well, then it needs to be on the other side. Again, we're going to get to something that are a little trickier. Just remember, it needs to move to the other side, always. And it needs to be the same distance. So if that was 7, that better be 7. And then last, we'll do the blue one. 1, 2, 3, 1, 2, 3. So this would be my, again, if I were labeling A, B, C, then that would be A prime, B prime, C prime, and I just connect them. And when you connect them, just kind of look at it, and especially if you're pretty visual, make sure it looks like it's a mirror image. Like that triangle on the right looks like we just took oh, if you can really imagine it, imagine if you folded that graph down the reflection line, those triangles should land right on top of each other. That's Mr. Fisher, one of the other teachers. He actually does that with paper and stuff. I don't know what you're going to be provided, and I don't know how well that would work on UOC or, but that would be something you could do. Like if they do give you graph paper that you could fold, you could do that as well after you kind of drew your graph out in your mirror or your line of reflection. But yeah, if I folded that graph on the y-axis on the line of reflection, they would fall right on top of each other. Yeah, hurry back because we're getting in the tough ones now. Tougher, I should say. I don't think any of them are super tough. Rip. Just can't have nice things. All right. Got it. Any questions on that? Again, that's the simplest version, but doesn't get a lot harder, a little bit harder, but not a lot harder, as long as you follow that process. Oh, real quick, I do want to mention one thing. What actually happened to my ordered pair? The values in them. The X's and the Y's. What happened? What part? So the X value changed. Did the Y value even change? The Y value didn't change, right? So my new ordered pair for this one just became 7, 4. My new value here just became 5, 7. And my new value here just became 3, what? So you'll also see notation. I don't know if I did this up above. Yeah, I didn't. You might see notation like this as another way. And again, this would be, if you understood it, it would just be telling you what to do. It might say X comma Y, and it would just tell you to do this. So they would just tell you to do the opposite of X. So again, that doesn't mean make X negative. It means flip the sign. If you see a negative like that, it means flip the sign. It doesn't mean X is always negative. It means if this starts as positive, then yeah, X would be negative. But if this starts as negative, just like all of these, then X winds up being positive. And then the Y value didn't change. So you might also see that notation. That's a reflection. It's a reflection over the y-axis specifically. Because all we did is we just changed the x values to their opposite sign. Y values don't change at all. That's the actual rule. If you read what I might hand out, the thing that I told you I wasn't really going to go over, that's the rule that is in there when you're flipping or you're reflecting it across the y-axis. It tells you to just do that. But again, I'm not going to try to have you memorize stuff because that's not going to last all the way, probably even to the midterm, much less the EOC. But if you understand that you're just flipping it over and the distances need to be the same, I think you can retain that. I hope. But you do need to understand what this means. Just take the original x and y, change the sign of the x, keep the y the same when you're flipping it or reflecting it across the y-axis. Any questions on that? All right, so I'm going to let you try to do this next one on your own. We didn't. Oh, actually, no, I'm sorry. I mean, I am, but that's not what I thought it was. So go ahead. Again, could have been written a different way, could have been in this. Triangle ABC. So write those points. Follow the process. Doesn't matter that the original image crosses over the line of reflection. You just follow the process. Those 3 steps you copy down on the slide before. Yep. I didn't really worry about it. The order doesn't necessarily match, just as long as you can draw the triangle with the line of reflection. I don't think it really matters. Give you like 2 or 3 minutes and you should be able to create that and do the reflection using that process. Grade, by the way, for the proofs are in if you didn't notice. See that yet? There's only 1 grade. I'm faster in this class. Oh, it's like I said. Huh? Again, I say that after almost every lesson. Some of them I don't, right? I think this one is again, follow the process. It gets a little trickier with what we're gonna do in the rest of reflections and then rotations. Actually, man, some people think rotations are as easy as translation when it's around the origin. Some people still struggle. So we'll see when we do it Thursday. Nick's still out. That's why I just checked hallway. Hmm.
Don't. What is it? Don't. I think it's like. Oh, okay.
Is that right? Chainsaw Mary? It's all part of that movie.
Are you going?
The movie, right?
No. You got another one?
No, none of you are going out. You need to be in bed early and then you up early. Nobody's going out.
You're fine. You're fine.
Nobody's going out.
Nobody's going out. But I'm there. Simple time. That's funny. What are you gonna do?
Were you a comedian in your past life?
Should be. Sometimes I think my job is a joke every day.
No.
I know it's supposed to be a generic version of the It guy. I was going to do Mr. Clean, but I couldn't find my.
That's
I really thought I knew where it was. I didn't look until this morning. But yeah, it wasn't in the because I have a thing with like costume stuff, but it wasn't in there. The makeup was in there.
You need a ball cap.
I have dressed up as a Publix manager before. That's actually I wear the black slacks I always wear and a green shirt, and then I put that on.
You did that.
Publix.
You did that.
Well, I was planning on doing the other thing, so I was in that whole Mr. Clean mindset, so I didn't think about it.
You should do that.
I couldn't find the earring.
You should go find the ring.
I couldn't find the earring. He has a big hoop earring, which I thought was in with all the other stuff.
You took it to Walmart.
Well, I didn't. I looked this morning. I would. They won't do it.
The balls have.
All right, so same process. What's first step? I mean, I'm saying after you have like draw the image in. What's first step? No. First step. Draw the line of reflection, super dark. Because again, when we do this other piece, you're going to get confused on where the line of reflection is. It's easier when it's the X or the Y axis. It's not as easy when it's not the X or Y axis. All right, so that's the only line I care about, my line of reflection. Now the rest of it's pretty easy. I just move each point to the other side, same distance away. So that's where that point goes. 3 away means 3 away. Where that point goes. And 1 away. And 1 away. That's where that point goes. Now it'll look kind of weird because we're crossing over the other image, but that can happen. It's not a big deal. Just makes it a little tough visually sometimes to see that it's correct. But they should look like a mirror image of each other. It's okay that they cross. The line of reflection is like the middle of the whole image overall. Like if you think of that whole image, that line of reflection splits that whole image into 2 equal halves. Again, if you folded it over, they would land right on top of each other. If you wanted to check your ordered pairs, remember the only thing that changes is the x's. The x's just become negative. So we should have -1, 1. Yep, -1, 1. This flips to positive. So +1, 7. Yep, +1, 7. This flips to +3, 4. Yep, +3, 4. That's the rule. The x value, when you're reflecting across the y-axis, the x value just changes sign. The y value does not change at all. All right, so now do this one. Same starting image. Actually, it's not the same starting image. So this is in a different spot. Make sure you draw it in a different spot.
Basically doing the same thing we did just on the x-axis.
Yes, correct. Exact same thing, only now instead of flipping left and right, it's gonna flip up and
The
down.
starting points, the blue, red, and
Yeah, use the values over there to put them on the ground. It's -7, 1, -5, 4, that's all.
negative.
Oh, man, I'm just gonna. I'm sure. Oh,
And then we're just going to the right how many times? Or no, you're going down, right? Translation.
Yeah, up and down. If you're going over the X, got to be up and down.
You're looking for
1, 2.
but then she's crazy. Ah. Yeah, watch him.
Done. I did.
But you're implying something else. What did you say?
I did not imply anything. You inferred something. See, what did you do?
What did you do?
Nothing.
He almost had to be like this.
No, I didn't almost say it. He totally knew what I was saying. Unless I'm driving.
Oh, you're driving.
Or my dog.
Well, I was after cussing.
Makes me sick.
You should come here.
And it's totally not his fault. I know that.
No, that
Still makes me
dogs
so
don't
mad.
understand mistakes.
Hmm?
Dogs don't understand mistakes.
They also don't understand what I'm saying.
My dog understands.
He does understand that I'm mad. He definitely knows I'm mad.
If you step on the ground, get that big, you think you're speaking.
That's why you apologize.
Exactly.
Which they don't understand.
You know, my dad drops my dogs. My dad dropped my dogs and she lost both of her front teeth.
Oh my goodness.
Yeah.
This right?
No, she's. And I my dog. No. It's like, get out.
I did. It was original right here. -7, 1. -5, 4. -3. Oh, yeah. I did do it wrong. But positive.
I can just tell by the picture.
I need positive to next to this.
Did I tell you my dog?
You show me your dog.
Huh?
You show me your dog.
Well,
What? Well, we gotta finish this. You guys might have a little time left over to work and supplies, but we gotta make sure we get through everything that the other class got through. Then we'll worry about that. All right. So once you've drawn the figure, once you've drawn the figure, again, this is not a difficult one. So what is my process? First thing I do is what? I darken the line of reflection, which in this problem is what? So now I'm darkening the x-axis, not the y. So that's this line going left and right. Make sure that is what you're using. Remove all the points. Now you just do the same exact thing. You put a point on the opposite side, same distance away. So if that's 1, 2 away, 1, 2 away. If that's 1, you don't go left and right. I think some of you try to go left and right. And then 1, 2, 3, 4, 1, 2, 3, 4. Always across the line of reflection. So the line of reflection changes. Sometimes the line of reflection is diagonal. So those are definitely the more difficult ones. If we connect those with our lines, it should be a figure that looks symmetrical, even though it crosses over itself. That's what you would get. Something that looks like that. And again, well, not again. What happens now to the x and the y values, though? X doesn't switch. Did the x change?
No, the line did.
The y is the one that flips now. My blue point now is still -3, but it's +2. This is now -5, -4, because it moved down here. This is -7, -1. So when it reflects over the x-axis, it's a different rule. So those of you totally tuned out, tune back in. You know who you are, right, ladies? So when you are reflecting over the x, now the x values don't change and the y value flips because you're flipping it up and down. So whenever you're doing stuff vertically, the y numbers are changing. If you're doing stuff left and right, the x numbers are changing. So again, this is a reflection over the x-axis. That's the rule.
You have to put that on the answer.
No, but I saw a question one year, I don't know when it was, where they didn't ask you to do the reflection. They just put this and they said, what is that?
Oh.
And you had to know that was a reflection over the x-axis.
The type will be on your test?
I kind of like it. I'm not saying it's not. Not saying it is.
Oh, we have such a lot of these this week.
Excuse me, Mr. Gill.
Yeah, what happened in one week?
When he comes back.
Well, it's better.
Yeah. We just said days up.
All right, so now here we're getting into the ones that get a little trickier. But again, if you follow the process, it's really the same thing. So again, we're going to move the points, not the image. Go ahead, first of all, create it.
I need a second. Just for on.
Oh, yeah, if you didn't take 2 pages earlier and you need more graphics.
Is this for reflection?
Still reflections, yep. There's a bunch. We have a we got to still do a diagonal line for reflections also. which we probably will go ahead and do in this class. Last period
No,
didn't
no,
get to it.
-5.
Yeah, it's not really. Does anybody else need more graph paper while I'm walking around? Anybody else? Yeah, let's do this.
Huh?
Yeah, this one's a little. So. I don't know.
Let me stop being sure. Let me stop being cringe.
Oh yeah, that'll be nice. That'll be. All right, so you should have that drawn. What's the process? Darken the line, but here's where it gets a little tricky. When we did the y-axis, what was the line of reflection? What did it look like? When we said we were reflecting over the y-axis, what did it look like?
It's up and down.
Straight up and down, right?
Which ones?
Kids make a mistake every time when we change it to y equals a number, because you'd think it'd be straight up and down, right? Nah. I know, right?
No, because you have to look like through it.
You just have to know how to graph a line. Y equals 2 means y better be 2 everywhere on that line. That's like that.
So you're not.
Because everywhere on that line, right? Y is 2. Y is 2 here. Y is 2 here. Y is 2 everywhere there. I do not draw a vertical line on the 2 because y wouldn't be 2. Y changes on that line. It goes up and down. So again, you need to understand when either y equals a number or x equals a number, so we're not using the axis anymore, then the line is no longer gonna be what you think it's gonna be. The axis is different than when we actually have a number value.
But we actually came back in the second half.
Yeah, I know. It was what 49-31 or something like that. Is that right?
Yeah.
I left before it was
We
over.
lost by a touchdown and a field goal. But
Yeah, the special teams.
The special teams. That's how we
Yeah,
lost
special
the football.
teams definitely.
There are
That's tough to
against
overcome.
Bluewater.
Touchdown.
Against Bluewater, they only had 100 yards.
Is there a specific special teams coach or?
Yeah, and he just got fired.
I was wondering.
What was that?
Now once you've drawn in the correct line of reflection, everything else is the same. Ignore all the other lines
Special teams.
and move each point to the opposite side.
Fuck it or
So again, that red needs to go to the other side 1 unit away. So if that's 1, that needs to be 1. The green needs to go to the other side 2 units away. And the blue needs to go to the other side. Again, do not stop at the x-axis. This is a mistake kids make. That's why I said darken that and ignore every other line. Because somebody's going to mess up and go 1, 2, 3, and then 1, 2, 3. The x-axis means nothing in this. It is the line of reflection that we are using.
So would it be
1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Wow.
So yeah, -3, 7. Because we're using this dark line, you have to ignore the x-axis. The x-axis is not the line of reflection. You got to forget that's there, which is hard to do visually. Every year, kids mess that up.
I think it's -5 and 3. I thought that was great. The color change. That was confusing.
Did I not? I might not have changed.
That's not embarrassing.
I thought the color change.
Oh, wait, no, I did. So that's -7. No, that's right. Never mind. Red is -5. This one. No, that's -5.3. And then I moved it. The one that I created isn't -5.3. And there's no rule. When you're reflecting over a number, there's no rule. You can't say the x becomes this or the y becomes that. You just gotta know how to graph.
That's not a
Again. Yeah. That is the graph of y equals 2 right there. Oh, they'll tell you what y equals. I'm sorry, they'll tell you what y equals.
Like, because you know how the first two probably did go like this, and then the second two were like this. How do I know?
Because they'll tell you where the line of reflection goes. You have to know how to graph the line of reflection. Yeah. This is telling you what the line of reflection looks like right there. You have to know what that means. If you don't, then you just got to remember it. What are you talking about? That's the line of reflection. Y equals 2 is the line of reflection. Oh. You have to know how to graph whatever I give you. If I say x, oh my goodness. If I give you x equals a number, you got to know what that graph looks like. If I give you, say, x-axis, you know what the x-axis is.
Okay, so I say x and y. Know where the.
Yeah, I've given you the question and it'll read every single time. Well, then you should pay.
I did it properly regardless.
Hold on.
You're the one that you're right. You don't know where. No.
It just,
You go, I don't know. I'm enjoying where to put those lines.
it's all,
Yeah, it's gonna tell you.
you gotta come back. Come back. Happy birthday. Fucking birthday. Here, I'll zoom out a little bit so we can get it all on the screen. So again, this is the part that I told you is the tougher part. When it doesn't say x, because if it says x, like reflect over x-axis or y-axis, you guys are normally fine with it. It's when it's a number, reflect over y equals a number or x equals a number. Or the next one we're going to do, which is even trickier. And maybe not. You have to know how to graph where that line goes. And really all you're doing is, I mean, you're doing what you did in algebra when you graph. You're just graphing a line.
On the blue line that you, it was -3 and 3. Why is it 5?
Well, I moved the net. That's the starting point. I moved it because this is the line of reflection, right? The dark line.
Oh, you started.
It's 5 away, then it needs to be 5 away on the other side.
Oh,
Ignore, I'm telling you, people are getting confused with the x-axis. I know you are. You have to be able to ignore everything with the line that you darken in. That's why you did it really dark. So you can say, that's the only line that I'm using. I'm ignoring everything else.
We should only lost 3.
Yeah.
We lost a clue.
That's the difference between good seasons and bad seasons. Is those games that you're like, man, we need that one back. Oh, you're looking for a mark? Okay. Yep, that happens a lot. All right. So now let's do. I think there's one more. Do that one again. So since we struggled a little bit with that one, do that one again. Oh, that might go off of your graph. Tell you what, let's do this. Still draw it in. So draw that in, but I'm going to change it to an X because otherwise it's going to go off your graph since it only goes to 7 on your graph paper. There, we'll make it across. X equals -3.
So it's up and down.
I'll let you take the shot.
Oh, it's negative.
So when you create the line of reflection, everywhere on that line of reflection, X better be -3. Your X value for every point on that line better be -3. If it's not, then you got the wrong line of reflection. Why is he so far ahead? Now they have announcements and that other stuff. Oh, you know why? Because some of this stuff I had to change in the middle of class.
One of the points are already on.
Oh,
So
see?
you leave it. You nothing with it.
If it doesn't, there's no left or right, and it just flips. Okay. Yeah, I can do that.
I just like finish.
You don't have a video. I'm assuming since it's a big red.
Yeah.
Holy.
Oh, look at that.
Not anymore.
Wow.
Pulled the muscle.
Oh, okay.
Yeah. All right. So again, you should, once you've graphed it, like once you put the image on your graph, the rest of it shouldn't be too difficult. Follow the process. You got to figure out where is the line of reflection if it says x equals -3. Well, it's everywhere that x equals -3. So if x is -3 here, that's the easy one to find. You just need to make sure every point on the line of reflection, x is -3. If you're not understanding that, then you just got to memorize it. If x equals a number, it's vertical. If y equals a number, it's vertical. It's horizontal. And then you should be good on the x-axis and the y-axis. That should be.
Oh,
Look
So
at
if x is a number, it's vertical. If y equals a number, it's horizontal. So now that is my line of reflection. That's the only line that matters. I don't care about the y-axis, x-axis, anything.
I mean, it says.
So,
if it directly to that number, you go with that number.
what's that?
If it directly to that number. Okay.
You talking about this number up here? Yeah, if it's an x, it goes up and down through it. If it's a y, it goes left and right through it.
And that's okay.
So now red is 2 away, so I need 1 2 away. Green is what? 4 away. I need 1 4 away. And what about the blue? It's on it, right? So it does not move. If it's not away from it, then it just is on it, stays on it. So that's my mirror image. And when you draw it in, it should look like it's a mirror. All right. So far, so good.
Easy peasy.
Here's the last 2 pieces. So sometimes you're not going to get that x equals a number or y equals a number or the y-axis or the x-axis. You're going to get,
Some BS.
it is some BS. You're right. That reflect across y equals x.
That's
Now
lovely.
again, you want to memorize it, you can memorize it. I prefer you understand it. All that means is where are all the points where x and y are the same number? So all the ordered pairs would be like this: -5, -5, -3, -3, -1, -1, 0, 0, 1, 1, 2, 2. Like those are the ordered pairs that make up the line, and then every ordered pair in between that. So it lines up looking like that, a diagonal line. Well, that'll be your line. I'm just kind of showing you. We're about to darken that in a second because again, go ahead, draw the triangle in, by the way. Oh wait, hold on. Use the other points though. Oh man, there we go. So use those. Don't use the ones I have written. Use the ones right there. So all of these just go down by 1. Just subtract 1 from all the y values.
So negative.
Well, just watch what I'm doing and just draw your triangle first.
-6 4.
Because that would have gone off your graph. So there. Use those 3 ordered pairs. and create the triangle on your paper.
God, my line is horrible.
-7, 4. Blue is -1. And red is -7.
What you do after you grab it?
Same thing you do with all the others. You need a point on the other side. So the line of reflection is that dark, or not dark, dashed green line.
I'm gonna just put that on my side.
So darken in. Again, you have to know that's where it goes. So either you can understand that you just create a line through all the points where the x and the y are the same number. So I gave you an example. We're just creating a line through all those points, and it would just go all the way across. 1, 1, 2, 2, 3, 3, 4, 4, -5, -5. Like that's what this means. Your x and the y are the same number in the ordered pair. That's all that means. So if you can understand that, you won't forget it. If you don't understand that, then you just have to remember if y equals x is the reflection line, it looks like a diagonal line going up from left to right.
You go right
Through the origin. It goes through the origin. So you got to
You
know
go
that.
to the right.
So it's a little trickier to do the opposite side. That's why I'm kind of letting you try. So if you'll notice though, I can't really count like how far away, like there's no numbers I can count to tell me how far away I am. Like it's not a matter of just going along the grid lines, right? When it's diagonal. So here's the only adjustment you have to make. And it's not that bad. It visually gets a little tricky.
Just a little.
Because you just have a lot of stuff going on the graph. So for the blue line, so pay attention. I don't just count in one direction.
We counting two, going two.
I'm going to go down and right. So I'm going to go down. Let me actually, here, I'm going to do this. I'm going to go down to the line and right to the line. Get that?
There you go.
Yeah. Oh, they can't wait to hear it. So I'm basically going to form a square is what I'm going to do. I go left and right to the line, and then I do the same thing from here. I go left and right and form a square. So I go down from where I hit the line. You'll notice we form a square when we do that. And that's where the point goes. Is on the opposite corner of that square. Because that ensures if I go left and right and up and down, it ensures that even though I can't count diagonally through here, which I kind of can, diagonal one, diagonal one, diagonal one, diagonal one. So it kind of still works. You can count diagonally if you really want to try. Doesn't always work out great. Like this point is a little trickier to diagonally see how to do. So again, create a square. Go left and right. Oh, I'm sorry, go left or right and up or down. So from the green, I would go. Oh wait, hold on. So again, I'd go to the right until I get to the line, and then down until I get to the line. Right.
You go to the right.
And now I do that same thing. Let's scroll down.
You just create a bigger square.
And then I'd go all the way out. It is always going to be a square, exactly. Always going to be a square, and then the far corner is where you put your point. So that's where that point will go.
How much you go down? The same. Go down the
So
same.
you make a you make a square.
Like this, like the
Again,
same
these
length I
will look
did
like a
here, I
square.
go on this
So
side.
whatever this number is, that number better be the same thing. So your numbers just match. Again. Actually, I shouldn't say it's. Yeah, I guess it is always a square. I was gonna say it could be a rectangle, but I guess it is always gonna be a square. So all your numbers should be the same. It's a square. I guess it will always be a square. I was thinking you could get a rectangle, but I don't think you can. Well, that's what happens when you take a bathroom break. I'm just saying. We really haven't even done that much. Let's. Oh, shoot.
Do that. I'm gonna kick you in the face.
That is not necessary. There we go. All right, so now again from the red, we would go.
This just looks like a big square.
So we go from that, and now. Oh wait, I didn't go all the way down. So there we go, and then I come. Again, should look like another square. All your sides should be the same length. So my point would go here. So if I draw that in, so the original triangle, if I put it on top of that, should land right on those points. Uh-oh. That's safer.
Gill, your square is off.
So again, that's the equivalent of putting a point on the opposite side, the same distance. It's just that we can't always, like, if the line is diagonal, we can't really like count the distance straight to the line. We have to kind of use two measurements to figure out where the opposite point would be on the other side.
Oh, shucks. I did wrong. Oh, that's.
That
Miss. Oh, wait. No, never mind. Don't move on yet. Please.
Well, I'm gonna move on and come right back.
Really hate me, don't.
Well, I just want to see what the next slide is.
Oh, okay. Well.
I'm gonna create another one of these, and you're gonna.
You can give it to me now.
Well, I have to create another one because I don't have one.
Oh,
Yeah, tell you what. I'll freeze it, and then I can create it, and then it'll be ready. So we need a new page.
why you down? Get off your phone.
Whoa, that was not right. Why is that not working? Mm-hmm.
That's not correct. That is not correct. Where's
so much, right?
It's not correct.
1, 2, 3, 4.
You got second. Oh, it's so. You got like 2 points right where your math point is still incorrect. Yeah, yeah.
Yeah.
Your square is still incorrect.
That's not close. I think when it comes to point on the triangle, but
You don't even have it.
It has to be on the triangle. Watch the.
All right, so here, try this one on your own.
I can't see it. You got it on groups. So I
Yep,
don't be
I'm about to.
3, 2,
See
1.
if anybody
3,
argued.
2, 1.
No, stop.
Right.
All right, so here are your 3 points. Again, if you didn't finish the other one, that's fine. Try to do this one on your own. That's where you need to wind up anyway. What? Holy cow.
No. Damn, but it jumped at you. Don't.
Knew that was gonna happen. I knew that was gonna happen. There. Raise your hand if you need more graph paper. Make more copies. I hope that they gave you more copy. So that's your 3 points you're using. There, that's your 3 points you're using. It's still over or y equals x. So again, y equals x means everywhere with the y and the x are the same number. So you're going to go ahead and graph across that dashed green line.
No. Oh, wait. Oh.
If you can visually see where the point goes on the other side, you don't have to do the left and right thing. Like this blue point, it's kind of easy to see. It's just going to go right there. Probably for some of you, that's fine if you can see that.
No. No. Yeah. You need one, Mr. Gill?
No, I've got mine up there. Thanks.
I like. Oh. Bro. No. Okay, can you guys everybody else got another one?
I don't know if I did this right.
Shut up.
My second one's bigger than my first one.
I told him that after clients for the x equals y.
Same thing.
But would it be that same line or would it be the opposite?
Well, it'd be the same numbers, right? If x equals y, they'd be the same number. Like the important thing is the ordered pairs. So if it's like there's no difference between y equals x and x equals y, because that just means the numbers in the ordered pair are the same.
What the please swap this one.
So I'm answering that question clearly and understanding. If y equals x, isn't that the case? That ordered pair works, right?
Yeah.
If x equals y, isn't it the same ordered pair?
Yeah.
Nothing changes.
So the
Yeah. Because it's the same ordered pair. Now there is one. Here's the next one that we're gonna do. Y equals negative x. That's different. Hey, I don't come up with what you have to learn. I just teach it. They tell me what you have to learn.
I didn't see that. You were I didn't see I'm so lost. They're way too long.
All right, I'll give you another minute.
Wait, is it a positive or a negative because we're substituting it? Is it positive or negative because we're sucking it?
Actually, there are rules for this, but just do the distance. I don't know what you're talking about. Well, you're just visually doing it. So you're visually saying, I need to draw a square. I need to go from this, which is kind of already done, sort of. You're just saying, I need to go right down and then complete the square on the other side. I'm about to do it in a second.
Okay.
You missed that part because you were out, so just follow along.
The first one.
The first one.
The first one.
-1.
Okay. And again, that's easier to see, but it's same concept. I would go to that,
No.
into that,
Right.
which,
Oh, I did that part right. Oh, wait, did the circle, I got it.
No, I'm
yeah,
right.
and then I would, again, you're just drawing a square in, and the far corner is where the point goes.
I did it. I'm finished.
Okay.
So the blue point would go there. And that's pretty, I mean, you can sort of tell, like, look at the blue point. It's diagonally, it's one away. Well, over here, diagonally, it's one away. And sometimes you don't have to do the square if it's pretty close to the line. If you can see that diagonally, you can just go 2 diagonals away. Then that's fine. Again, as long as you know it's the same distance, but on the other side. No, you should not. Should not get a rectangle.
No, I'm still.
Yeah, this last one we're doing right here.
Yeah, are you getting us kidding or something else?
I'm gonna say it's fine.
So again, that would be where your green goes.
Okay, so
I'm telling you, mine is right.
So your triangle would be like that.
no.
The red one doesn't move because it's on the reflection line. It makes kind of a cool little triangle-y thing in the middle.
Just it's prime.
Why is it?
You got it
really
right.
built your dog.
Mr. Gill, congratulations. I got the first word right.
All right.
Yeah, see, Logan, you're down.
I think it's just
Down.
it's the hard.
Thumb it in, thumb it not. And I don't think, I think this is more difficult than rotation, actually. This last piece. All right, so that's your final 3 points right there. You should have come up with -1, -1. You should have come up with +1, -1. And then 1 point didn't change. 1. 1, 2, 3, 4. And 4 didn't change.
Your dog? No, I got it right. Hey, my dog's a champion. Your mother.
I get 1.
No, it's probably good for
And my dog is too.
I know it's one time.
My dog hit you.
Don't test your.
Oh, that's wrong. I'm sorry. 1, 2, 3, 4, and 1 is the green one. So you'll notice what happens in these. What? Where are my other plants?
No, I can't.
4 and 4, 4 and 1, and then -1 and +1. So there is a rule for this. Last thing. If that is your line, so everybody tune in. If this is the y = x thing, if you get that, the rule is you just switch places. The x, y becomes y, x. So if you notice on all my new ordered pairs, 1, 4 just became 4, 1. 4, 4 just is still 4, 4. Or 1, -1 became -1, 1. So if you just want to memorize that, whenever that's the case, you're reflecting it over y = x. You just flip or you switch places with the y and the x in the ordered pairs. Or you can remember how to do it.
You gonna do when it's trying to be you going hand there, but
I have some candy.
I
my dog did my mother's chest.
I want one. Give me first.
I have
I
Skittles.
want Skittles.
I have, you don't get Airhead, that's for birthdays. I have the gummy, fruit gummy, generic, they're generic. Or Starburst.
Where did he go?
Generic.
Oh, what else?
Skittles, Starburst,
I
gummy.
was trying to get him a bed.
Yeah, Skittles.
He wakes up.
Can I get the two in your hand? Get two.
Or one of.
Grab the purple. Thank you.
Oh, look at that. That worked out perfect. What do you want? Skittles, Starburst, gummies.
Me too. I ate them.
You gotta give me one. I like to get them turning. I gotta like to get Skittles.
Yeah.
You can't have Airhead. That's for birthday.
My birthday's on me.